Welcome to this Maths Made Easy video on differentiating exponential functions. And to start with, let's take a look at how we would differentiate here a to the kx. And to start with, let's just note that a and k are real numbers here. Now we could actually prove this result here using implicit differentiation. However, for this video, we won't be concerned with proving this result, just stating the result here. Now to start with, let's write this in a form that we can differentiate. So we could write this as f of x is equal to a to the kx. Now if we differentiate this, we would obtain f prime of x. And when we differentiate this here with respect to x, what we obtain then is ka to the kx. So ka to the kx times by the natural logarithm of a there. Okay, and that's the result we obtain when we differentiate a to the kx. Moving on now to take a look at differentiating e to the kx. Well, to differentiate e to the kx, first we just need to be aware that if we differentiate e to the x with respect to x, we just obtain e to the x again. So if we note that first, d by dx here, or e to the x, well that simply gives us e to the x there. Well, in this case then, again, let's just write this e to the kx in a form that we can differentiate. So, if f of x is equal to e to the kx then, well in that case, if we differentiate this, we would obtain f prime of x. And again, differentiating this here with respect to x, we simply obtain ke to the kx there. Okay? And this rule here is actually just an extension of the previous rule. If you let a equal e, so let a equal e, then if we differentiate this here, we'd obtain f prime of x simply ke to the kx times by the natural logarithm of e. And remember, the natural logarithm of e here is simply 1. So this part is just 1, and therefore all we simply obtain is ke to the kx, as we would expect here. Okay, so that's what we obtain when differentiating e to the kx there. Moving on now to take a look at differentiating e to the f of x. Now here we must use the chain rule. So if we let u be equal to f of x, and let y be equal to e to the u. So y is equal to e to the u. Well, in this case, we can also write y then, using the fact that u is equal to f of x here, as e to the f of x. Well, in that case, du by dx, so du by dx, is simply going to be f prime of x. So just differentiating u here with respect to x, and in that case if we differentiate y here, and dy by dx, sorry, dy by du here, that would give us e to the u here. Now simply all we need to do then is apply the chain rule. So therefore dy by dx is going to be equal to dy by du times by du over dx. And in that case here then, all we're going to obtain then in this case is f prime of x here, that's my du by dx, times by dy over du, which is e to the u, but we know e to the u is e to the f of x. So that gives us e to the f of x there. Okay, and therefore that's the result that we obtain when differentiating e to the f of x there. And finally, moving on now to differentiate the natural logarithm of x. So first what we'll do here is write this in the form y equals the natural logarithm of x. Now we're going to use a bit of a trick here to get this in a form which we can easily differentiate. So what we'll do first here is take the exponential of both sides of this equation. And if we do that, what we obtain is e to the y equals e to the natural logarithm of x, which would simply give us x. So e to the y is equal to x. Now if we differentiate x here with respect to y, so therefore dx by dy, this would simply give us here e to the y. However, we've already noted here that e to the y is simply equal to x. So dx by dy is just simply x here. Now what we actually want is dy by dx. We want to differentiate y here, which is the natural logarithm of x, with respect to x. So therefore, if I just simply take the reciprocal here of dx by dy, then we would obtain dy by dx. So dy by dx here is simply the reciprocal of x, which would give us 1 over x there. And that gives us the result here for the differential of the natural logarithm of x. Now we can generalize this result using the chain rule. So using chain rule here, our general result then for d by dx for the natural logarithm of f of x. In this case, this would simply give us f prime of x over f of x there. Okay, so that's how we use the chain rule there to find our general result when differentiating the natural logarithm of x. And that concludes this Maths Made Easy video on differentiating exponential functions.